Hey, it's Majenta Strongheart from Supply Frames Design Lab, and today we're in San Francisco at Autodesk Pier 9 facility. Let's go catch up with Paolo.
I'm part of the team that runs the residency program, and we invite artists, engineers, designers, you name it, architects, etc., to come to the Pier and work for 4 months with our tools and software. Currently set up for a meeting. Different artifacts made by different residents. A resident maybe 5 years ago, eventually she ended up going to MIT to get her PhD, but she played with the idea of like, what if I use the different techniques available at the Pier to do music, like 3D printed record versus laser cut, paper, wood, objet, all the different things. Another piece you may have seen is John Edmark's piece. It's a 3-dimensional Zoetrope. Press the button. Cool, huh?
Yeah.
Only by changing the flicker rate. I remember when he first came here, he had an artichoke and he put it in the lathe, and he was spinning the artichoke in the lathe with a strobe, trying to figure out if he could. It was really good to watch him, like, to see an artichoke spinning, and he's like, I got it, I got it. And we all came over and we're seeing it totally do what you're seeing here, which was kind of neat. And
Just
so,
an artichoke and a strobe light.
right. Talk about our equipment. It looks like we're in the middle of moving things around. There is a part cutting on the 5-axis router right now. And this is a current resident. He's machining a vertebrae.
Do you know why he's machining a vertebrae?
He's right now working on a workflow for other projects, and he just picked something, scanned it, and he's trying to basically get familiar with the tool, the software, etc., and then move into a larger project. We have people with technical knowledge on hand, and often in the beginning they'll review your files and review what you'd like to do just to make sure it's feasible, but they don't do the work for you.
Right.
And so it's just kind of like, and they're around, you know, there's a couple of them around, and 9 to 5 for sure, sometimes on weekends, and then even sometimes after hours. As a resident, you have 24-hour access to the Pier. So a lot of this, everything on the upper floor you can do with just a buddy, and everything on the lower floor that's bolted to the ground, you need to have an approved, exactly, somebody who can take care of you if something needs to be done. Yeah. Let's walk over to the 5-axis Matsura, poke our head in that. It looks like you might be making a fixture for a tombstone. Okay. And so the way that normal 3-axis machine works is the bed can kind of move in 2 and the head moves in the 3rd. You've seen those. This one has a trunnion that's part of the bed, so it can swing towards and away from you.
Oh, wow.
And then it has a rotary table, and so that it can rotate around that as well. And so you can get pretty elaborate geometries. When you have high-speed machines that go above, let's say, 15,000 RPM, you can't use the normal collet or set screw systems that you're familiar with. This is a heat shrink system, and so what you do is you heat the tool holder, it expands, you put the tool in it cools and closes, and that's what the machine over there does. And so that puts it in. And then the next one is to dynamically balance it. And so what it does is it spins the tool holder up to some ungodly speed, and it makes sure that it won't vibrate. And if it needs to, it modifies by drilling into the tool holder to balance the thing at 50,000 RPM. And then what it does is it comes over to the machine you asked about. It measures the diameter, the length, the number of flutes, and then programs an RFID tag in here. And then when you take this over into the machine and plug it in, it reads the ID tag and it knows the type of tool, et cetera, and it also logs the life. So as the
so you
tool,
can set up your tool libraries and just have them super reliable, ready to go,
ready
precise.
to go. Yes, that's
awesome.
the dream. That's the dream.
Wow, can we just pull some of these drawers out?
We can, definitely.
This is just beautiful.
And so this would be an example of a collet and a nut that would be harder to balance than something that was vacuumed or heat shrunk in place.
So once they're put in there, they don't come out, right?
They do, because you can heat it back up again and pull it out.
Okay, great.
I mean, when's the last time you broke a tool?
Yeah.
You know how that goes.
Yeah, you don't want to sacrifice the whole holder every time.
Yep, exactly. And so, all of that, and so we have a pretty comprehensive tool library.
Yeah, library, definitely.
With all the goodness. And let's head over into the wood shop. Table saw, wood turning, chop saw, edger, planer, you know, kind of what I consider to be
the
standard.
necessities.
Exactly. Necessities plus with a view.
setup of the shops is amazing. What was the evolution of that? Did they have everything figured out and designed before it was installed, or it sort of happened as the machines were acquired? Or?
Because of the fact that we're over the water and on a pier, a lot of the heavy machines had have extra pylons put underneath them and pads poured. So when we were going through the scene, you might have noticed that some of those machines were taller or higher or different, and so that's to take the load. In this particular shop, none of them are that heavy, and it was just basically a workflow study of like what machines are going to be used, how often, how does material come in from the outside and get processed through the space. In the other room you saw the rotary tools for the wood-based stuff, and then kind of have all the rotary tools for metallics. A bender with an amazing view, more clamp ranks, material handling. Mostly for aluminum, and then we have a metal cold saw over there, bandsaw, welding class being taught right now. The print lab, right? Wow. 5 polyjet printers, all with different material combinations. 4 laser cutters for non-ferrous materials, laser cutter for ferrous materials. Cleaning stations, workstations, FDM printers in the back there. And then kind of right around the corner here, we have kind of artifacts from all the different types of machines that we can go over and have a look and talk about.
Yeah, that'd be great.
There it is. Yeah, both of those are. That one's dipped in, I think, cyanoacrylate from a new package that we've been working on, a new software package called Generative Design, Autodesk Generative Design. And the promise of this software solution is that instead of the classic kind of take a block in CAD and slowly subtract material until you get a bracket, you simply describe the mounting points, the load point, and the load stresses. And then you let the software
connect it for you. Wow.
Right? That's the promise of the software.
Because it's interesting, it looks very skeletal almost, more so than really geometric.
And to be fair, a lot of these algorithms are derived from looking at nature. And the goal is eventually to get what we call to multi-physics, which is right now we're looking at static loads. Eventually it would be nice to add aerodynamics, heat, thermal, and so all of a sudden now, think about a bicycle helmet. It has to be able to take an impulse. It has to be super light. You want all of the heat and moisture to get off of your head, and you also want it to be aerodynamic. You want it to go through, so like that's a really nice multi-physics challenge. And how do you get to the end point? We ask for residents to propose a project, and so much depends on the project, the rest of the people applying, what machines are available, what teams are available. And so I would say early on, the largest collection of people who applied were makers and artists, and then the rest of the world found out. And we got the architects, the PhDs, the engineers, the designers, and so the number of applicants and the breadth with which the people are applying has just grown greatly. And I feel like my main duty now is just connecting. This person, that person, how do we get it done? Yeah, it's really fun.
Well, that's important too.
Yeah, definitely. You can just do it, just practice. Grab the bar and then roll all the way to the other side.
Wow. Was it weak?